Hello, everyone. My name is Vinay. I am doing this course project for managing machine learning projects. So this is my submission. So my problem description is I would like to choose a weather forecasting application where we can get forecasting of weather by days for 90 days in advance. Currently, what is available more reliably is 10 days. This will be important for farmers as they can plan in advance what they want to grow and so. Is there a problem? Yes, there is a problem. The current weather prediction by days goes up to 10 days with a 90% problem accuracy. We need to extend it to 90 days. Can machine learning solve it? Yes, it can solve it. We're talking about gigabytes of data, terabytes of data, which need to be analyzed and presented with forecasts. Does someone care? Yes, many people will care. There will be farmers who will be impacted, and then there will be the food and the prices and everything which goes along. Let's evaluate the CRISP-DM model. Business understanding. While defining the problem, the target users, farmers, problem 60 days in advance, by day weather predictions, why it matters. It will empower farmers to take better decisions. Current state, historical seasonal data, and probabilistic weather patterns. Defining success. Expected impact, improved land utilization, metrics, dollars per hectare, targets, let's say X percentage improvement. We use the MSC. Constraints, the predictions need to be delivered every day for 60 days in advance. If you were to identify the factors, they will be the historical weather, wind, gusts, sun, etc. 12-month, very broad weather patterns, historical weather patterns versus actual weather by the days, seasonality, historical data understanding. So the source of the data will be all the weather forecast bureaus and companies. Considerations, how much data, maybe 10 to 25 years of data, depending on the sensitivity and the cost. We like it to be a low sensitive data, meaning there shouldn't be much variance. Validate significant missing data to be identified and the period separated. Region-wise data quality needs to be monitored. Different weather department data accuracy also needs. How will we prepare for the data? Define different features like inputs. We'll have temperature, wind, rain, snow, sun, etc. Output can be probabilistic day forecast of same features. Interaction between features needs to be studied. For example, temperature and moisture can impact each other. Wind velocity can impact temperature and moisture, etc. Possibly missing features can be around land conditions and vegetation, which can impact movement or weather conditions. Modeling, model selection. Given the balance of performance and interpretability, I would recommend a simple regression model. And if there is complexity in data, then look at adding weights. And if data is very high, then look at creating a neural learning network with multiple models. Evaluation. I will create test sets, validation sets, acceptance data sets, and follow the due diligence. Deployment, deploy and follow the SDLC with monitoring and alerting. Retraining can be every quarter with release of actual historical data. Data validation, use a combination of heuristic methods like mean, median, etc. to determine consistency in data. Solution validation, this one requires a bit of slow start with small set of features and validation with shorter time periods, existing model for accuracy and output, gradually then compare it, all the while versioning such subsets of data models and comparing them across and finally settle and determine if the model was accurate or start from fresh. And keep recycling till the final may have a combination of few models that at a neural network level will have weights to run. Machine learning system design, cloud versus edge. Cloud should be okay because we're not looking at immediate changes every day. By the minute or the hour, we just need changes every day. Offline versus online learning has to be online as the data keeps getting updated. Batch versus online predictions. Predictions can be a combination of batch for hourly predictions and online for daily predictions. Potential risks in production. Training server serving skew. Given the data is pretty deep and wide and pretty old, and we will be using certain element of heuristics, I do not expect much training serving data skew. Data latency can be there as daily data will need to be collated across the different geographical locations and put back into the model to predict the output for the day. Data drift can be possible as circumstances will keep changing and weather patterns will keep changing. Vegetation depletion can affect weather patterns. Concept drift should not be the case as the model is working on data predictions. Thank you very much for listening through this project. I am going to stop the recording and stop sharing.